Imagine a world where education is fully accessible to deaf learners. Today, that vision is becoming a reality right here in Kenya. At just 22 years old, Norah Kimathi is the co-founder of Zerobionic, a startup that builds AI-powered humanoid robots that translate speech into sign language. Backed by the UNDP and NVIDIA, Norah's startup has successfully assisted more than 500,000 students across Africa. Join me as we learn more about Zerobionic and the incredible technology that's changing lives. Norah, seeing what you built at Zerobionic is truly remarkable, and I am so impressed. If you could just give us a little backstory about how you got into tech and how you started Zerobionic.
So for the past 4 years, me and my team had been moving from school to school, training young students on science, tech, engineering, and math. We were moving from these schools with an organization called Young Scientists Kenya that also trains young students of the same. So on a number of these sessions, we happened to encounter some students who couldn't speak and some could also not hear. So we asked the sign language interpreter, why are these students being left out of the concepts that we are trying to explain? We are trying to teach them robotics, we are trying to teach them chemistry, but they're just nodding their heads. They're not understanding what we're trying to explain. So the sign language interpreter just told us that these students are only taught basic human communication. So they are taught things such as hello, my name is, such things, but then they're not taught complex concepts. And that's why, for example, if I may ask, have you ever seen a deaf pilot? Deaf doctor? Deaf engineer? Yeah. Simply because these complex STEM-related concepts are non-existent. So no one has built a data set around that, and if it's there, it's very small to minimal.
When we started out, we wanted just to kind of help out and have kids across the continent kind of access educational access STEM for where they had been left out. But then moving out, we saw that this is a problem that is not only faced in Kenya or not only faced in Africa, it's a worldwide issue. And how we could expand and how we could move from just being a ground solution for Kenyans to a ground solution for the world. So a lot of economic impact in the making. So started deploying and saw that need for schools to kind of adopt these airports, hospitals, public spaces, conferences, and then that is where the economic side of Zerobionic essentially came in. So if you can deploy hardware into these spaces, these guys are usually very willing to kind of have the space inclusive and pay for inclusivity. Yeah.
So what you can see here is a reflection of what we have here. So let's start with just signing A. So it signs A, and then C, we have D, we have E. So it just goes spelling every single letter that you could possibly think of. So, and then now if you want to send it, let's say, to the hardware to mirror exactly what you're saying, just reflect your hand so it's able to pick up on the exact motions you're doing. So whatever I'm having here is a Rococo Smart Glove. So it's embedded with so many sensors on it, so it's able to make up on even the slightest of movements that you make, such that even if I make a small change in my joint, it's able to pick up on that. So at the moment, we've achieved a 92% accuracy rate as a result of that.
And building the first prototype, I know it couldn't have been easy. If you could just tell us, how long did it take to build that first prototype? And are there some challenges that you ran into, especially in the beginning?
So our school was really supportive. So Strathmore has some really massive engineering labs. It's well equipped with adequate resources for students. So our first prototype was actually made out of recycled tires. You see, it was quite rough because that's when we were just starting off. We didn't have anyone who laid a foundation for us because this was something that was previously non-existent. So we are currently the ones who are laying a foundation for builders, founders, CEOs, startups who want to build in the same space to have an easier time than we had. So at that time, the first ever prototype took us roughly 7 months. So before we could even just go pilot it in a school, it took us 7 months. And that was just building the hardware. We haven't even gotten into the software bits of things. So the software, obviously, we were improving it over time based off of the students' feedback and based off of the distance factor. Because you'd find most of the time maybe we want to train these students when we're in Nairobi and the school is probably in Garissa, and we just want to have like a 2 or 3 hour mentorship session with them. So those are some of the factors that we'll consider while building the software bits of things. So that took us that period of time. But then as we speak, with advancements in AI, tech, machine learning and robotics, whatever would take us 9 months can take us 2 or 3 months as we speak. So having that supportive ecosystem of the schools, our friends, an amazing team that you just met inside was really instrumental in just us accelerating our growth.
We are essentially pioneering humanoid exoskeleton robotics across the continent, and we are also trying to see how this can be integrated in our learning environments and different specific regions across the continent. So I'd say hardware and manufacturing is a really key factor that we are currently banking on, instead of just doing something that wouldn't make sense to a lot of students or schools in the grassroots levels.
So at the moment, this is just being finger spelling.
Yeah.
And I think that's the biggest challenge we faced when we were starting off, because we realized that it can only do so much. So you'd find that whatever would take someone maybe 3 minutes to say, it will take this 5. And that's why we now move to having a full robot that can do sentence spelling. So it can do it at the same period of time that this person is talking.
So how has the feedback been for the students who have engaged with the robots? How has the feedback been?
Yeah. Honestly, it's been much greater than we expected. You'd realize that demand is outpacing us. We have more demand than we can actually supply. And that's why for us, we actually don't view people as competitors. We view them as enablers. But for us, we don't have any competitors. We're just working together to ensure that the demand that we have can actually be fed into. The supply can feed into the demand that we have. So for the past two months, we've been doing a lot of data collection, and we've been seeing in terms of STEM comprehension, there's been a 75% increase in STEM comprehension in these deaf students, something that was previously non-existent, that they weren't comprehending, that they weren't even receiving. So it's been insane just seeing this. And probably by 2027, we hope to have our first cohort of deaf engineers out in the public. We're excited to see how that will go.
Yeah. Oh, wow. Awesome.
Absolutely.
Yeah.
We are really fortunate to be backed by a lot of organizations that are pushing for accessibility. And one key factor that we are having across the world is that every place is now going accessible, where accessibility is not a leisure but a requirement for a lot of these spaces. So financially, we are still figuring that out, because also what we are working with very new deployments and technology across Africa. So there's not that proven model in the world right now for robotics. Even the West is still struggling around figuring out robotics and financial status across the hard equipments. But it's a journey we've done over the last 2 years, and it's a trajectory that is really picking up.
Hello, my name is Gregory Kimathi, machine learning and computer vision engineer, and this is my colleague.
Hi, my name is Sam Alela, machine learning engineer at Zerobionic Africa. So we are behind, basically the brain behind AF1 audio output and vision, and basically how it talks and interacts with humans. We are going to do a small demo of how it works.
Oh, hey, Marka. You look good today. You are still watching that thing on the laptop. What's up with NVIDIA anyway?
So actually, this is a characteristic of how you look.
So this documentary, is it just talking about graphics cards, or are they explaining how these things actually work under the hood?
Yeah, so actually explaining how you work. Yep.
Showing the guts of things? That sounds pretty intense. I wonder if they show how I work inside. You think they cover something like that?
Yes, they do.
So, what part of this are you finding most interesting right now?
Tell me how you use AI to talk to me.
Oh, that's a big one. How I talk? Well, it's not just one thing, honestly. It's like a bunch of different systems talking to each other really fast. Basically, when you say something, my processing units take all those sound waves and turn them into text first. Then there are layers that predict what the most natural sounding response should be based on everything we've talked about and what I know general. It's a mix of pattern recognition and generating language that sounds, well, like me talking to you right now.
So you mentioned that the robots were first made from recycled tires and now they're made from recycled plastics. Why is it so important that the robots are made from recycled plastics, and what impact does this have on the environment and the impact that it has for Zerobionic?
So when we were starting off, we realized that our target audience was mostly schools and institutions that were mostly in areas that couldn't afford a 1 million Kenyan shilling robotic exoskeleton that is made out of metal. So we were looking at the cost factor of it. How can we subsidize this cost so that these students are able to afford it, their schools and institutions, so that we can bring equality and access at the same time? So we then decided to build it out of recycled plastics for the cost factor when we were beginning. So it reduced our manufacturing cost by over 60%. This allowed us now to reduce the cost as well that we sell to them, and that we even lease, because we also lease for events, these events that happen in schools, the hackathons, tech conferences and events for students and even for adults as well, where advanced engineering concepts are being spoken about. So that way we're just able to bring inclusion into spaces without having the cost factor on the table. And then as well, with the recycled plastics that we've been collecting, we're able to provide employment opportunities to street-involved youth. Because they collect the plastic, we give them money or food or books to just sustain themselves and continue with their education or just make meaning out of their life. So we give them employment, they give us the plastic, we conserve the environment, so it's a win-win for everyone. And then, so at the moment, we've recycled over 10,500 kilograms of plastic waste. We hope that number can reach to 2,000 tons by the help of ecosystem builders, by the help of these collectors, just by the help of everyone else who's concerned about conserving the environment. Because one of the biggest concerns is that the robots are coming, yes, but then what will be the environmental impacts of them coming? So it's more of how can we bring advanced technology into the country but still offset the negative impacts that it has.
Hello, my name is Benjamin. I'm a mechatronics engineer at Zerobionic. I'm working on the humanoid, making the joint movements more human-like. And maybe what I should show you right now is to try making the joints move and testing out their limits. So here is just an interface, web interface for controlling the joints via web. So if I can move maybe a simple joint for a shoulder, the right shoulder. So can bend the elbow. So on and so forth. Even the moving the joint movements for the head. And nodding still. So we're continuing to make it more human-like, and I hope we get the good results here.
So hi guys, I'm Norah Zerobionic humanoid lead, and today I'll be presenting to you our platform, our software bit of sign language translation. So right here we have our platform where sign language gets to translated from text to speech and speech back to sign. So right now what you can see is a facial landmark capture. So it captures my face and also my fingers. So any sign I do, it gets to capture. Any facial expression I also do, that gets to be captured. Let's try with this character. Hello world. So what you can see here is speech now being fed to our AI model that gets to translate it into sign language, so that those with hard of hearing can now see whatever you actually do say. So this is how we now get to capture the data to train our robot. So we are using the Rococo motion capture suite. So any motion that he does gets captured and it's translated into a format we call FBX. So our model is fed the FBX data and that gets to train it. After the annotation, we now have a humanoid do the same signs that was initially captured. So you can make any movement. Yeah, so as you can see, anything it does clearly gets captured. So using this format, it's way faster and more accurate. So we have a high quality data set for now training the humanoid.
I'd say hardware is a really interesting space, especially at this point in time where we are seeing like a lot of advancements towards the OS, robotics, and a lot of things. And so hardware is actually having its GPT moment at this point in time, where we are seeing like a lot of developments accelerating towards the hardware side. But as a continent, we are still struggling with some equipment. So you'd find manufacturing is one of the toughest things you can ever do in the continent. Accessing electronics, accessing basically talent that people can actually do and bank on. So you'd find that in Kenya, we don't have robotics engineering as a course or as a unit across all the universities. So what we have is mechatronics engineering. So what you do is you get people who have basic knowledge in mechatronics and then kind of try and train them on robotics as a subsection. And doing that also increases your time, your turnaround time. So you have to train first and then have them now deploy. So talent is also a very key issue across the continent, and if we can see more individuals and more people get into hardware and robotics as a unit or as a course, and then accelerating some of the things we do across the continent will become really easy.
And now, Norah, with the rise of AI and how it's changing a lot of things and a lot of jobs, how has it impacted Zerobionic? And is it something that you're worried about? Yeah.
Funny enough, the biggest question we get every time is, are the robots going to come under our bed at night and finish us, when we're asleep? But then I think I tell people, the robots are gonna come, It's like AI. People were afraid of it, but it was inevitable. We use it every day. We use Claude, we use DeepSeek, we use ChatGPT. But then they're going to be in our hospitals, they're going to be in our kitchen, they're just going to be everywhere. So if they're gonna come, why don't we ensure that they're built with dignity and access, such that you can be able to interact with a robot, I can be able to interact with a robot, a deaf, a blind person can also be equally able to interact with a robot. So for us, it's not coming to substitute us, it's coming to complement us. So it's able to do the tasks, the repetitive tasks that we ideally do every day, but then now it leaves us to the creative aspects of things. So we are able to think more clearly, we have more time to do other activities. So it's coming to complement and not just substitute us. So it's more of an enabler than, something that we should be afraid of. So for us, honestly, as I say, it just fast tracks our process at a much faster speed. Right now, we are moving at such an exponential pace because of AI. We would build a robotic hand so probably right now, we can build 5 arms in a span of 3 months. In fact, 3 months is a lot, probably even 1.5 months. With these advancements, and especially now when we get a robot that we can use for manufacturing, things will be insane because you know the robots that are used in the manufacturing industry, they're able to scale production in minutes, leave alone hours. So things are done in actual minutes. So I think we just need to embrace the change, especially as Africa, so that we're not left behind the AI race and the robotics race.
And now I've seen that you've been recognized for all your work. You've gotten many awards. How did it feel getting that first award? And how do you feel now getting all this recognition for the amazing work that you're doing?
So for me, the awards that I get are usually more of a mantle that I'm given. Even when you check most of my captions when I'm posting about an award, I usually say that I hope that this award opens up doors for so many people alike, just like me, and just like everyone that I'm working to build for, and not just personal recognition should not supersede the intention of the award. So for example, winning top 40 under 40 women, I now have the responsibility to open up the door for so many other women in the industry, in the ecosystem, and just build them up to reach to that point. If it's a Youth Innovators Award I've gotten, now I have the mantle for the youth to open up that part for them. So for me, it's mostly not a personal recognition, but more of for the community. It might have my name, but it should feel like it's for more than one person and not just a personal accolade. Yeah.
Oh, that's awesome. And are there days when you feel like giving up, when you feel like it's too much? Are there days, and how do you deal with that?
So the first time we went to pilot our robotic arms, I met a young girl who, after seeing it work, understanding what was being explained, just came up to me and told me that her dream of becoming a deaf pilot can finally come to pass. And that's why you'd find I use the example of a deaf pilot very frequently, because every time things get tough, things get hard, I'm always just remembering her words. So it just pushes me to be better. It pushes me to push my team to be better. And it just pushes us in hard times when we feel like we want to give up. You'd find many of the times that we're sleeping here in the lab at night, it's not because we don't feel sleepy, it's not because it's not cold at night, but it's simply because we know the people we are building for, maybe few or no one is building for them. So we want to be there for them, we want to enable them. So it just takes the sacrifice of us to open up a new pathway for so many other people, to open up pathways for others. Yeah. So this is where we have most of the compute power that we use for the training, for the voice control that you've just seen, for just all our build processes in general. And then on the higher bench, you can see a couple of the awards that we've gotten. So at the moment, we've impacted over 510,000 beneficiaries. That's both directly and indirectly. So by the end of 2027, spanning into 2028, we hope that that number can reach 1 million beneficiaries. But at least we can see that our work is making a difference. People actually want to use this technology, and we can continue to have a ripple effect, not only in Kenya, Africa, but also on a global scope. So we want to build something that outlives us, something that is built by and for the people we are building for. So 5-10 years from now, you'll probably see Zerobionic being read by purely, if not 90%, the people who we are building for at the moment.
For every other disabled person or any other person watching outside there, disability is one thing that nobody chooses to kind of live with. And so if we can make lives better with tech and hardware and all these advancing technologies that are coming in from every corner of the world, then it means we have a world that is factored in and inclusive. And that is just my message to kind of everybody outside there.
Zerobionic is an excellent example of what happens when innovation is driven by purpose. What was once a barrier to education is now being tackled by the power of technology. If this story inspired you or made you think, hit the subscribe button and share it with someone who would love to see it. Thank you so much for watching, and I'll catch you guys in the next one.